Hi, welcome to the LinuxFest Northwest 2020. My name is Chris Van Tyne, Chief Technologist for the West Coast at Red Hat. Today I'm going to be talking about microservices and databases with Kubernetes to help accelerate application delivery. And my contact information is listed below. If you have any comments or questions, feel free to reach out. I spent a lot of time talking with companies, and a lot of them are struggling or figuring out, how do I accelerate innovation? Right? How do I foster a culture that supports innovation? They may be very good at executing and deploying at scale their vehicles across the globe, but how do I innovate that vehicle more rapidly and deliver new capabilities so that I'm a differentiator product or service out in the marketplace, and I keep my competition at bay, and I satisfy my customers what they need. So in order to innovate quickly, innovation accelerates the more dynamic and policy-driven type of culture and organization, because you're able to keep your pulse on the market or your customers and then accelerate your response. Think about a traditional car company. It takes them 12 months to iterate their vehicle every year. And so the time to respond to a change is at least 12 months. Some product cycles are more than a year. And think about a newer company like Tesla. They're able to deliver software updates over the wire, and they're able to evolve their product or service much quicker. They can listen to their customer and then not wait for a hardware cycle, but actually accelerate software cycle to deliver that capability over the wire. Maybe it's new battery efficiency improvements, better 0 to 60 time, or an entertainment feature, or an improvement to the autopilot, just to make that product out in the marketplace that much better without having to go to a dealer lot, without having to wait 12 months to roll that into the next revision of that vehicle. And even more impactful is that it can help drive top line growth too, because they can offer new innovative business models, such as a subscription service, to these new capabilities as well. So a vehicle is no longer just a one-time sale. And so many companies are looking internally to their IT organization is, how do I have a similar capability that the Silicon Valley companies have? How do I keep pace and become that innovative company for my industry, right? And so the software factory, take a look at that. Back in the 90s, the fab was a differentiator. Well, before that, Toyota had their car factory, which was a key differentiator, and Google, Facebook, they all have their what I call a software factory that allows them to rapidly release new software. And if you take a look under the covers, it's built on culture, process, automation, and technology. From a cultural perspective, a lot of these companies are quick and nimble because they have small groups across multiple groups. And it's very similar to how open source communities are organized, right? They're open, they're collaborative, they're transparent, and that fosters innovation. Open source communities are widely known for being very innovative, whether it's in containers today, data services, the Linux operating system, etc. A lot of innovation because you're leveraging the contributions beyond just a single company or organization. And then secondly, they're highly automated, just like that automobile factory or the Intel fab, highly automated, able to deliver new capabilities quickly with high consistency, high quality. In the software world, that's enabled through a continuous integration, continuous delivery DevOps model, and being able to deploy that on infrastructure that scales up and scales down, and be able to deploy that quickly because I've defined my infrastructure as code. And now I have the recipe for how that needs to be built, and I can abstract that from the cloud provider and quickly deploy one cluster, multiple clusters, anywhere that I may need them. And then from a technology perspective, you look under the covers, they're increasingly leveraging more and more open source tools because it is where the innovation is happening. And they have a multi-cloud, hybrid cloud strategy because their customers have to meet certain compliance. So they need their data, their applications in a certain geography, or it needs to be offline, right? Or they need the ability to rapidly scale up and scale down. And you see these applications that are being deployed broken down into microservices, cloud native, so that individual components can be updated, not requiring the entire application. And that allows you, when you break it down, to be able to deliver that much quicker and iterate faster. And so those are some of the key ingredients to enabling a software factory. And from a technology perspective, Kubernetes is increasingly becoming a key ingredient of that because it was designed as an orchestration engine to really accelerate innovation, accelerate delivery of new software, and be able to operate that at scale across any provider, whether it's bare metal, virtual, private, or public cloud. And you get all those things that you need to move fast, like the ability to quickly respond and adjust accordingly, ability to scale up, scale down, to be able to recover quickly, to be able to deploy highly available across availability zones or racks or regions or providers, and be very efficient, right? As you move to a consumption model in consuming public cloud, efficiency is key because every resource consumed is an extra dollar on my bill. And security, right? Increasingly, we see Kubernetes as a way to standardize your security across multiple providers and abstract the differences. And when you have this one platform, right, think about the efficiency of my development team. Rather than building tests against each provider, I can build and test against a single provider, being the Kubernetes platform, even though it's hosted on many different platforms under the cover. And from an operational perspective, I have the same tooling, whether it's monitoring, logging, same runtime, the same full stack across these providers. And so my reliability of this platform is going to be that much higher because I've eliminated the drift from different providers. And I don't have to maintain any abstraction code or to abstract away the differences. So I've reduced that technical debt, right? Kubernetes automation is some of the key things with Kubernetes to enable this. One is orchestration. It allows you to define your application in a declarative way and deploy it at scale. For instance, I have a web application, 2 web front ends and a single app. I've defined that. I have some images to support those applications in my registry. And then out in my Kubernetes cluster, I have a set of nodes. These can be physical VMs or cloud instances. And then Kubernetes has an orchestration engine, which go ahead and schedule that. So I could trigger that through the GUI or CLI or API. And in this case, it's to deploy my web and app, create a container within a pod. A pod is one or more containers. It'll find an available node. And then Kubernetes front ends that pod, collection of pods that have the matching labels with a service so that it can load balance the traffic. And then for my web front end, I can create an ingress and route external traffic to the web. And so that's all highly automated. I didn't have to open a network engineering ticket. I didn't have to manually figure out where to schedule these nodes. It was all done automatically for me. The second thing it does that helps expedite delivery is it also maintains the health of my application. So when it comes to an issue, I don't have to get a page at 2 a.m. to fix a broken web server. Kubernetes will monitor that web server, and if it's broken because it's declarative, it'll try to maintain a desired state of 2 web servers, 1 app server, and schedule a replacement in this case. And it did that by labeling the pod, in this case, role of web, and then the service has a selector of role web, and so it automatically picked up that pod. Now it's going to be routing the traffic, and then it dropped the deleted pod that was broken. And it also allows you to auto scale, so you can efficiently use your cloud resources, minimize overall costs by starting out with a baseline number of pods, but then allowing you to set triggers and thresholds that if it's exceeded, then to scale out and deploy additional capacity to meet the load of your application. For instance, 80% CPU threshold was reached, so it's going to deploy another application pod and automatically add that into the service based on the selector label matching. Now, when it comes to microservices, Kubernetes is a great platform because it allows you to quickly deploy your microservices and bring a CI/CD pipeline on top of that. So when it comes to a CI/CD pipeline with containers in Kubernetes, here's kind of the general flow is you have your application developers checking in code and their deployment definitions for Kubernetes, as well as the configurations. And you could then proceed to building your container in your development environment, right? This would be the development namespace in Kubernetes that's isolated from UAT and production, for instance. And what happens is that when I build it, it'll build out my container image. I store it in a registry, and then I can deploy that to my development environment, test it out. Once it's approved, it can then be promoted to the UAT environment, and then I can put it into the registry or check it for being approved for production rollout, and then it could be deployed out to my production cluster in this case. Right? So there's a general flow that you would see in a CI/CD with containers. And Kubernetes comes with some built-in continuous delivery deployment strategies to help update your applications at scale and also be able to experiment and try things out so that your developers can deploy and create with confidence, right? So to be innovative, you have to have that ability to experiment and throw things away if it's not successful. And so with Kubernetes, you can do different types of deployments like a recreate, a rolling update, a blue-green, and an A/B testing. And we'll show you how. First, let's go through a recreate. So recreate with downtime. This is when you want to update version 1, in this case, out in my cluster of your application with a new version. This is the simplest way, is that you can actually just delete version 1 in your cluster, and then your next version 1.2 can be deployed, right? There's some downtime, right? But it was very clean, simple. I didn't have to worry about schema compatibility between the versions. I didn't have to interact with my developers. I just took that new version, deployed it. However, there was some downtime. Another option is rolling updates. So Rolling updates allows me to replace each pod one by one, right, and control that as I gain more confidence to go from 0 to 100% and moving from version 1 to 1.2. And so one of the things I can also do with Kubernetes is make sure that I don't lose capacity. So I can set the max surge to 1 and also max unavailable to 0, so that I just add one at a time and I don't decrease my capacity. And so here, I'm going to show you, I built 1.2, and now I'm going to gradually roll it out in my cluster, and you'll see one by one, it gets updated. So here I have 50% updated. Load balancing traffic through the Kubernetes service across the different versions. And I'll be able to monitor and see how it's working, and if it's successful, then I can go all in to that deployment with my rolling update. And that's nice because it allows me to gradually roll out. I'm not all in right away. It also allows me to roll back if there was some sort of issue and there was 0 downtime, right? So reduce risks. And the con is that I have 2 versions out there at once. So if I have a database in the back end that the application is talking to, I need to make sure that it's compatible. And I need to develop my schema, my application accordingly. So typically, the current version and maybe N-1 versions will be able to live side by side. And then I can eventually drop that backwards compatibility as I move to the next version. So operations, development, collaboration, key part of being successful here. Another option is the blue-green deployment. This has a little bit lower risk because here I'm deploying my blue environment with version 1. All my traffic's going to that, and my selector is routing that through the service. But then I have version 2, and I'll call that the green environment. So that application can be deployed in a completely separate instance, and the service can then be updated so that its selector routes the traffic to those pods that are labeled with version equals green. So I have all my traffic now routing over there. The blue traffic eventually, dies off. And the blue environment remains so that if there is an issue, maybe in the first 5-10 minutes, I can always either scale it down or leave as is and roll back, right? So maybe there was some sort of issue and then I could roll back to the blue environment. So it was lower risk because, hey, I never even touched the blue pods. And so all I did was adjust the service to go from green to blue and vice versa. So low risk, no downtime. Also allows me to get production-like testing. And like the rolling upgrade, I could do the rollback as well. There is some additional resource overhead. And of course, I have 2 versions, so I need to make sure there's data schema backwards compatibility. Now, deployment strategy is also a good way to enable the developers to be innovative and try things out, experimentation. So I'm going to show you some A/B testing. And it's key because, you want to be able to foster that culture of innovation, try things out, and IT has your back, right? So in this case, I have application version A and version B. Version B, I want to experiment, try out a new recommendation engine, see how that works out. So version A is out there, I get a 25% click rate. I'm routing the traffic based on the selector and the label matching. Version B, I want to deploy that. And so I just update the selector and I drop the version. So now it matches all versions. And it's the route 75% traffic versus 25%, right? So just experimenting, And that's based on the number of pods. That's why it's 75-25. And then once I get comfortable, because I got a 30% a better conversion rate, I can go all in and drop or add the version selector so that it only goes to B. A traffic will eventually die off as well. And so that's some of the deployment strategies. Now, one of the key things also is how do you quickly switch maybe from one database to another as well. Maybe as I move from dev to production, I want to quickly move to the production instance. And so Kubernetes, you can leverage external services. And one of the things is that database may live initially outside of the Kubernetes cluster. Right? So you have your app running in the Kubernetes and in the database, maybe it's on a cloud provider. So how would you do that in Kubernetes? So I have my web app running as a pod in my cluster on Kubernetes, and I want to connect to my Mongo database. I have two of them. I have my red and blue one. But I don't want to have to rebuild my container every time I switch or deploy a different one that's statically set with the connection info. And so with Kubernetes, you can leverage what's called a service with a cluster IP type. And I can define Mongo as the connection name. And then I can define the port of the appropriate, in this case, and I start with the red database that lives on my external cloud provider. And I can define an endpoint for that service with the IP of my red database service. And so I could then, as I move from dev into production, I could update the IP address of the endpoint. Right? I didn't have to touch the pod or the container image of my web app. All I did was send an update to the Kubernetes resource kind of endpoint with the name of Mongo to this new IP address. And so that allows me to efficiently switch from dev to my production instance. Now, some cloud services require the URI with a static external name. You could use that as well. In that definition, you just use the external name rather than the cluster IP. Okay, the next step is probably to move that database into the Kubernetes cluster. And so one of the things that Kubernetes provides is a concept called stateful sets. Right? This is another type of deployment which allows you to maintain a sticky network ID name across restarts, right? Mongo 0, Mongo 1, Mongo 2. If you restart those pods, it will maintain the same name, which is nice because if it fails, you want it to come up with the same name, even if it goes on to a different node, for instance. And as you create additional and you scale out, you want it to be ordinal in terms of the index that's automatically added to the end of the name, appended to the name. So name 0, name 1, name 2, name 3, name 4, etc. And then also this construct in Kubernetes allows you to have stable and persistent storage by linking it to the ordinal index name. And then it also has a mandatory headless service for integrations as well. So let's take an example of this, right? So if I have a database stateful set and I want to have two replicas with direct access to the pods, I have my Mongo client wanting to access the Mongo database. And so go ahead and deploy an instance to one of the nodes. It's called Mongo 0. The storage is mounted through a persistent volume claim and backended by the persistent volume. That Mongo 0 is read-write. Now, if I scale out Mongo, it's going to be Mongo 1, and that's going to be a read-only instance, right? And then I could scale out again to Mongo 2, and that will be read-only as well. Now, one of the things with running a database like Mongo and Kubernetes is that there will be health checks, and if there's a failure, it will automatically recover. And so in this case, it failed Mongo 2, but it brought it back up on node D, and you notice it maintained the same name, Mongo-2. So that was consistent and persistent through a restart. So a nice feature within Kubernetes, so I don't have to manage that manually as well. So databases in Kubernetes is certainly possible with enterprise storage capabilities, as well as the ability to scale out and recover your databases in an automated way. Next, database migration. So one of the key things and challenges is we talked about deploying applications quickly, but how do you deploy database updates quickly in Kubernetes in a CI/CD pipeline? What you can do is use a database schema version control tool like Flyaway, which is open source. And you can define the database schema in a SQL file. And here I have version 1 in production, version 2 in test, and version 3 in development. And what I want to do is push these new versions through the pipeline. And so in order to do that, what I can do is first version 2, right? So version 2, I wrote a migration script to update the schema. And this schema would be backwards compatible with version 1. I would want to make sure of that, especially if I'm using blue-green or I'm using rolling updates. And once I define that migration script, I could then build a container instance or image with the Flyaway tool and the SQL migration script. And then I create a image, in this case, Flyaway MyDB, and version 2 reflecting version 2 of the database schema. And I store that in the registry. Now it comes to my Postgres. I'm running version 1 of the schema. What I can do is I can create a job, and this is a type of deployment in Kubernetes that just runs at a single time. So think of this kind of like a cron job. And it will run that job on an available node, in this case on the C. It will pull down the Flyaway image, and it'll start it up. And it has an automated script that will then trigger a connection to the database. In this case, I just provided the connection via secrets. And it will go ahead and upgrade the schema to version 2 of that Postgres database. And I didn't have to bring it down. It automatically took care of it for me. So those are just some quick tips on how Kubernetes can help you in enabling the management of microservices and databases at scale in a containerized environment with Kubernetes as the orchestrator. And as a result, when you have that capability and you empower your developers to experiment, try things out, you can really accelerate innovation and help your business stay ahead of the competition. So thank you so much for joining in. Feel free to reach out with any comments or questions that you may have. Thanks.